So today we're going to be looking at graphing and writing linear equations, all of which is a review from Algebra 1. So pause the video if I go too fast, and then write down what you need to, think about what you need to, ask questions. All right, here we go. So we've talked about what relations are. Today we're going to talk specifically about a linear relationship, which is a straight line. Remember, not all relations are functions. And most all of our linear relationships today are functions with the exception of a vertical line. So linear relations can be expressed as x plus y equals 8. It can also be written as y equals mx plus b. So that's just a different form. All right, let's move on. So let's look at slope-intercept form first. It is the most popular form. It is the most useful form. So I'm going to write up here that slope-intercept form is useful for, it's an O, for graphing. Oh, yeah, for graphing. That's what I want to put. And so that's really the emphasis of slope-intercept form. We can see slope, and we can see the y-intercept. So that's where the name comes from, slope and y-intercept. So linear equations are often written in slope-intercept form, and it says here, it's got an and or an or. We're just going to look at one form. I don't like the other form. So we're going to look at y equals mx plus b. So we are not going to look at the different way that some people might write slope-intercept because this is the most popular way, where m is considered your slope. We'll talk more about that here in a minute. That's an E. And b is the y-intercept. That's where the graph crosses the y-axis. I am going to start all over. My handwriting is atrocious today. I apologize. Okay, so slope has a whole bunch of ways to look at it. So generally, we use the letter M for slope. And you'll hear a lot of people say that slope is rise over run. But you have to know what direction rise is and what direction run. Oh, in other words, you've got to know, am I rising and then running, or am I running and then rising? So think of it in terms of sitting in a chair. If you're sitting in a chair, would you rise and then run out the door? Or would you run out the door and then rise out of the chair? If you run out the door before you rise out of the chair is going to still be stuck to you as you're running out the door. So you have to rise up out of the chair and then run out the door. Now, I said rise up out of the chair. Technically, you can rise up or down. Imagine falling out of the chair. That is a negative rise. So rising can be in the direction of up or down. Running is in the direction of right or left. So what does that mean? Well, your rise is your y direction because it's up down. So you can also see slope as change in y, that triangle means change, over change in x. Or we can use the actual formula, equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So this denotes your change in y, and this is your change in x. So you are responsible for knowing this formula right here. It will not be given to you. So the more times you write it down, the more likely you are to learn it. So let's look at the 4 different types of slopes. So there are 4 types of slopes. We have a positive slope, we have a negative slope, we have a slope that is 0 and a slope that is undefined. So I'm just going to sketch the graphs of these slopes. So a positive slope tilts in the positive direction. So as you're looking at the tip of this line, it is pointed in the positive direction, meaning this quadrant right here is positive. This quadrant right here is a negative quadrant. So if you look at the tip of the line, it's pointing towards the positive direction. If it were tilted the other way, as you look at the tip of this line, it is pointed towards the negative quadrant. So quadrant 2 is negative, quadrant 1 is positive. Every line that has a slope, theoretically you can walk on it. If you can't walk on it, it does not have a slope. So when you look at 0 and undefined, 0 slopes and undefined slopes are either vertical or horizontal lines, but you are responsible for knowing which is which. So 0, having a slope of 0 is an actual number. It means that there is no incline. It's not steep, it's not shallow, it just has an incline of 0. So that would be representative of the floor in your house. So that would be a horizontal line. So you need to know that if you have something that has a 0 slope, so m equals 0, you need to know that it is called a horizontal line. And you need to know what the equation of that line is. So anytime you have a vertical or horizontal line, it's going to be x equals a number or y equals a number. So which is which? So look at this line. It is going through the y-axis. This right here is the y-axis. So let me write that on there. So this is your y-axis. So this line is going directly through and intersecting this y-axis. So it's going to be y equals whatever number that it's crossing on the y-axis. So in this case, it's going through the y-axis at some negative value. Maybe this value is -2. If that's the case, this would be y equals -2. Then look at the undefined slope. Undefined means that you can't walk on it. We cannot walk up a vertical wall, let's say. So a wall would be an example of a vertical line. You cannot walk up a wall unless you have help. So not many people can walk up the wall on their own or by themselves. My students always tell me that only Jesus and Spider-Man can walk up a vertical line. So your vertical line might look something like this. You need to know that that slope is undefined. You can use UD to shorten up the word undefined. And you also need to know that it's called a vertical line. And then finally, you need to be able to write the equation of that line. So just as before, this line is going through the x-axis. So again, vertical and horizontal lines have equations that are x equals a number or y equals a number. It depends upon what axis that line is going through. All vertical lines are going to intersect the x-axis. So it's going to be x equals whatever number it's going through. So this is going to be x equals some number. Okay, so on this particular slide, we are going to write the equation in slope-intercept form if it's not, and then we're going to graph the line. So I'm going to make these a little bit bigger so that you can see what I'm doing and straighten it out. Maybe. I have no idea what I just did there. I don't know, but it was fun. Okay. So for this particular example, this is already in slope-intercept form. It's in y equals mx plus b. So when we graph an equation, you have to have the y-intercept first. So our number one job is first, you need the y-intercept. So in this case, the y-intercept is equal to the 7. So we're going to start on the graph at 7. So you always start plotting a point somewhere along this y-axis. So you always start at your y-intercept. So I'm going to put a point right here at 7 on that y-axis. Then, step 2, you want to stair-step your slope. So the slope is the coefficient of x. So in this case, the slope is 2 over 5, which means that we have a rise of positive 2, so that's a direction that's up, and a run of positive 5, which is a direction to the right. So from that y-intercept, I'm going to go up 2 and to the right 5. I'm also going to need to go in the opposite direction because I need to fill in my line in both directions. So if you change the sign of your slope and change both the numerator and the denominator, you'll get the same value. So if I change the positive 2 to its opposite sign, which is a negative 2, and change the positive 5 to its opposite sign, I get a negative 5. And so two negatives make a positive, so both of these have the same value. However, their directions are different. So a negative 2 means we're going to go down 2, and a negative 5 means we're going to go left 5. So here we go. I'm going to stair-step my slope. So I'm going to start with the first slope, and I'm going to go up 2, which I'm going to go a little off my graph, but I'm just going to estimate it, and I'm going to go to the right 5. So from here, I'm going to go up 1, 2, and to the right 1, 2, 3, 4, and then 5. I'm going to plot a point right there at up to 5. And then I'm going to go down to, from here, I'm going to go down to 1, 2, to the left 1, 2, 3, 4, 5. So I'm going to plot a point there. And if I go down 2 again and over to the left 5, I'll be just a little bit off the graph, but I'll be there. And then I'm going to connect those points with a straight edge. It's difficult for me to use a straight edge on my iPad, so don't do as I do, do as I say. And there's the equation of that line graphed. Then let's look at number 8. So for number 8, it's almost in slope-intercept form. We are going to swap out the function of x for y. So I'm going to rewrite it as y equals negative, and I'm going to write the coefficient of x as negative 1x. So I'm going to write that negative 1 as a fraction. So negative 1 over 1, because I like to view my slope as a fraction, x plus 2. So the first thing I need is my y-intercept. So my y-intercept is the constant 2. So I'm going to start at the y-axis on 2. Then the second step is my slope. My slope is equal to negative 1 over 2, or I'm sorry, negative 1 over 1. And so a rise of negative 1 means I'm going to go down 1, and a run of positive 1 means I'm going to go to the right 1. I also want to look at my slope in the other direction. So I'm going to change the negative 1 to its opposite sign, so it becomes a positive 1, and then the positive 1 in the original fraction to a negative 1. Both of these slopes have a value, an overall value of negative 1. On the second slope, a rise of positive 1 means I'm going up 1, and a run of negative 1, I'm going to the left 1. So I'm going to plot these. So for the first one, I'm going to start with the first direction, and I'm going to go down 1 to the right 1, down 1 to the right 1. I'm going to plot a point every time, down 1 to the right, down 1 to the right, and I'm going to fill it all the way in. So here we go. Okay, so then I need to go in the opposite direction, up 1, left 1. So I'm going to go from here again. I'm going to go up 1, left 1, up 1, left 1. And I'm just going to keep going and plot a point every time I go in my 2 different directions until I'm done. And then I'm going to connect with a straight edge, best as I can. I'm a little off, whoopsie doopsies, but you get the idea. All right, one last one of these. So I'm going to make this one bigger. Okay. Now this one is not in y equals mx plus b form. I need to solve the equation for y. So that's my first job. I'm going to solve it for y. So here's my y term. I need to get rid of the x by subtracting x. So then I get a 3y is equal to, now you could write negative 15 minus x or negative x minus 15, but slope-intercept form requires the x term to come first. So I'm going to write negative x and then minus the 15. And we're almost done. So then to solve for y, I need to divide by 3. When you divide the right side by 3, divide each of these individually by 3 because we have to break them up anyway. So the 3's cancel, and I get y equals. Then we need to take this x out of the fraction and set it off here to the side. So when I take x out of the fraction, all that's left is this negative. But remember, it means it's a negative 1x divided by 3. So when I take the x out of the fraction, I'm going to have a negative 1 in the numerator and a 3 in the denominator. So my coefficient is negative 1/3 x. So I get a slope of negative 1/3 x. And then negative 15 divided by 3 is negative 5. So my y-intercept is negative 5. And that's where we're going to start, is with a y-intercept. So the y-intercept is negative 5, so we're going to go down 5 on the y-axis and plot a point. So that's our starting point. Then we're going to plot our slope from that point. Now my negative is kind of hanging out to the side right now. You can either put the negative in the numerator or in the denominator, but not both places. And we'll actually end up doing one of each. So one direction of my slope is a negative 1 over a positive 3. Then you want to switch both signs. Your other slope direction is positive 1 over negative 3. So a rise of negative 1 means I would go down 1, and a run of positive 3 to the right 3. A rise of positive 1 means you would go up 1, and a run of negative 3 would be to the left 3. So here we go. Down 1 and to the right 3 would be here. Do it again, down 1 to the right 3. Then we're going to go in the opposite direction because I've run out of room. I'm going to go up 1 and to the left 3. Up 1 to the left 3. Up 1, and I'm a little off, but to the left 3. Then connect your points with a straight edge. And there's the equation of your line. Then we need to look at, in this case, not how to graph a vertical or horizontal line, although you are responsible for knowing how to do that, but let's just read this graph and write the equation. So first of all, it's handy to know, you might be asked, is this a vertical or a horizontal line? And if, and depending upon which one it is, write the equation. So this is a vertical line. It is going through the x-axis. So since it is going through the x-axis, it is going to be x equals some number. And the number that it's hitting on the x-axis right here is 1 to negative 3. So it's going to be x equals negative 3. And then you might also want to write here that this is a vertical line, and you might be asked, what is the slope of this line? Since you can't walk on it, the slope is undefined. And so I told you could use UD to abbreviate undefined. So then look at 12. 12 has this line here, which is a line we can walk on. It's like your floor. So since we can walk on it and it's going through the y-axis right here, the equation of that line is going to be y equals whatever number it's going through on the y-axis, which right here is 1. So it's going to be y equals 1. There's the equation of that line. So as you can see, vertical and horizontal lines have x equals or y equals a number. It only has one of the two variables. Then you might want to add in here that this is a horizontal line and you might be asked its slope. Since you can actually walk on it, it has a slope, but it is a slope with no incline. So the slope is 0. Now let's write slopes using the point-slope formula. So the point-slope formula looks like y minus y sub 1 equals m times x minus x sub 1. The more times you write this, the more likely you are to learn it. And so just as the name says, point slope, you need a point and the slope in order to use this formula. This formula is best used for writing equations. So it is useful for writing equations. So the slope-intercept form is useful for graphing. That's its main purpose. Point-slope form, its main purpose is for writing equations. Now we're going to start out in point-slope, but we're going to finish and write our final answer in slope-intercept form. So as you can see, I have a point and a slope. So this point is going to be plugged into this green x sub 1, y sub 1, and this slope is going to be plugged into here. The plane x and the plane y are going to stay put. So I highly suggest that you rewrite the point-slope formula, but only write in what you're not going to substitute in. In other words, write what I call your template. So you've got y minus, and then you've got a space, and then equals a space, and then x minus, and then another space. And so this right here is your x sub 1, and this is your y sub 1, and of course you have your slope right here. So my y sub 1 is 7, so I'm going to put a 7 here, and the reason why I want you to write your template first is because when I replace, in this particular case, the x sub 1 here with this one, you're going to have a minus 1. If you try to substitute as you write the equation, most students will write x minus 1 instead of x minus a negative 1. So a huge caution, that's a huge error that kids make, and so it should look like this when you substitute it in. And then your slope is going to go here. Then all that's left is for you to simplify. So anywhere that you have double negatives, you're going to make it into a big plus, because a minus minus is a plus plus. So the first thing I'm going to do is change this to plus plus. I cannot add the 7 to both sides right now because I have these parentheses. You have to distribute first before you ever add or subtract anything to both sides. So we are going to distribute the negative 4 all the way through. And so the y minus 7 doesn't change. Negative 4 times x is negative 4x. Negative 4 times positive 1 is a negative 4. Now you can add the 7 to both sides. And so you end up with y equals negative 4x plus 3. So this right here is your slope-intercept form. This right here would be your point-slope form. I'm not going to ask for that, but if somebody does, that's your point-slope form. We're going to finish it in that y-intercept form. All right, another point and a slope. So I'm going to move this one over so we have a little bit of room. So we're going to do the same thing again. Start with your open template, so y minus space equals space x minus space. So this is my x sub 1, y sub 1, and this is my slope. So my slope is going to go here. My y sub 1 is a negative 5, so you have a minus minus, and your x sub 1 is a negative 6, so again another minus minus. I'm going to take care of those double negatives by making it into a big plus, and then we're going to distribute that 2/3 into parentheses before we subtract 5. So I have y plus 5 equals 2/3 times x is 2/3 x, and then I'm going to multiply the 2/3 to the 6 slowly for you. So a positive times a positive is a positive. 2/3 times, and I'm going to put the 6 over 1 because I'm multiplying it to a fraction. So you could do 2 times 6 is 12, divided by 3 times 1 is 3. So 12 divided by 3 is 4. Or it would be quicker if you canceled out. So the 3 and the 6 are diagonal to each other. They're both divisible by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So what you end up with is 2 times 2 is 4. Over 1 is still 4. So no matter how you do it, you should still get a 4. And now I can subtract the 5. And I get y equals 2/3 x minus 1. All right, so now we're going to have 2 points. Before we had a point and a slope, now we're going to end up with 2 points. So when you only have 2 points and no slope, you're going to have to do a little bit more work. So, as it says here, I'm going to make this a little bit bigger again. So to write a linear equation, given 2 points, x sub 1, y sub 1, x sub 2, y sub 2, and remember that just means the sub 2's mean that this point belongs to point 2, and the sub 1's mean this point belongs to point 1. You're going to use the slope formula followed by the point slope formula. So to remind you again, the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And again, your point slope formula, y minus y sub 1 equals m times x minus x sub 1. So, first up, you got to find slope because you have to have slope and a point. Well, you have 2 points and no slope. So first and foremost, we are going to find, I'm going to make this even bigger because it'll give me more room. Okay, so, a little crooked too, I think so. There, it's about right. Okay, so step 1, we are going to find slope. And I'm only going to do 2 of these. I'm not going to do all 4 of them. So I'm going to use my formula. Well, even before I use my formula, in fact, I'm going to erase this so I have room. I want to label my points as x sub 1, y sub 1, x sub 2, y sub 2. So I want a little bit of room there. So then we're going to find our slope. So our slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The more times you write that down, the more likely you are to learn it. So then I highly suggest that you write the template down first because you're plugging in negative values behind a subtraction sign. You're bound to forget that it's a minus minus. So y sub 2 is 7. So the 7 is going here. Then y sub 1 is 1. So our 1 will go here. X sub 2 is going to go here, and that's negative 3. And finally, x sub 1 is here, and it's got to go here, and we're putting that negative 6 there. So we do have one instance of this minus minus, which is going to become a big plus. So I'm going to immediately change that to a plus, and then we're going to do the math. So 7 minus 1 is 6. Negative 3 plus positive 6 is 3. 6 divided by 3 is 2. So that's our slope. So we're going to use that slope. And then you can choose either one of these 2 points that you want. It doesn't matter which one, but you got to make a choice, this point or this point. I tend to look for points that have fewer negatives or none at all, either a 0 for the x or the y, or the lowest number possible. So in this case, either one is equally detestable because of the negatives, so I'm going to choose this point. So then the second step is going to be use point slope. I'm going to put P/S for point slope. So y minus y sub 1 equals m times x minus x sub 1. I'm going to write my template and plug in. So my slope is 2, and my y sub 1 is 1, and my x sub 1 is negative 6. So like we said before, you got to change that double negative into a plus, distribute the 2. So you've got y minus 1 is equal to 2 times x is 2x, and 2 times 6 is 12. Finally, I can add 1. And my final answer is y equals 2x plus 13. All right, so then let's look at number 4, and we'll be done with this section. So again, the first thing I want to do is label my points x sub 1, y sub 1, x sub 2, y sub 2. I'm going to find my slope first. So this time I'm not going to write my formula down, but you should if you don't know it. So m equals, and I'm going to put my template in here. The first number should be my y sub 2, which in this case is 8. The second number is y sub 1, which is a negative 2. Then down below, the first number is x sub 2, which is negative 6. And x sub 1 is negative 2. Change any of your double signs, which we've got 2 of them, to a big plus, and perform the math. So 8 plus 2 is 10. Negative 6 plus 2 is negative 4. Both 10 and 4 are divisible by 2, so you get 5 over negative 2. So there's my slope. And then you choose a point. It doesn't matter which of these two. Now I know this one has 2 negatives, and that one has a negative and a positive, but it has bigger numbers. So I'm going to choose this one only for those of you who might have chosen it inadvertently, and you know it's got the double negative. So I'm going to choose to plug that one in. So here's step 2. I'm going to use point slope. I'm not going to write out the full equation. I'm going to write the template. But again, if you don't know it, you should be writing it out. So y sub 1 in my case is negative 2. If you use the other point, you are going to get the same exact answer as me once we're all the way finished. My slope is 5 over negative 2, and my x sub 1 is negative 2. Change any of your double signs to a big plus, and then we're going to distribute the 5 halves, negative 5 halves. So I get y plus 2 is equal to negative 5 halves times x is negative 5 halves x. Negative times a positive is a negative, and again, I'm going to multiply this out slowly. So the 2's cancel. Or you could do 5 times 2 is 10, over 2 times 1 is 2, 10 divided by 2 is 5. So I get y plus 2 is equal to negative 5/2 x minus 5. Finally, you can subtract 2. And our final answer is y equals negative 5/2 x minus 7. So now we're going to look at linear applications. So I'm going to make this a little bit bigger. It's really word problems. It's a fancy word for word problems. And so you've got to set up your word problems correctly. And so the first thing says a cab ride cost $4 plus $1.75 per mile driven. So you need to look at that because we're using slope-intercept form for these equations. And slope-intercept form, which again, to remind you, y equals mx plus b. There is a variable part, which is whatever is being multiplied by x, and a constant part. So remember that earlier in this video we talked about slope being a rate of change. And so anything that's something per something, miles per gallon, miles per hour, price per pound, all of those, anytime you use that word per, it tends to be a rate of change. Not always, but it tends to be. So you're looking for that here. So as I look at this cab ride costing $4 plus $1.75 per mile, there's that per. This $1.75 per mile must be the variable part and must be that rate of change which goes in front of the x. Then you're going to pay $4 whether or not you go 1 mile, 10 miles, or no miles. And so that's your constant. It's going to go where the b is. So they've asked you here to define your variables. So we're going to define those variables. So I'm going to let x. So I'm going to let x equal, because my variable amount, the thing I know absolutely nothing about, is the number of miles driven. So that's what my x is going to be. Because if I knew the number of miles driven, I would multiply it by $1.75 and then add 4. And then y is going to end up being your total cost for that cab ride. So when we write the equation, we've got y equals the m, our variable, is our $1.75 per mile, so 1.75 per mile. Well, our number of miles is x. And then we're going to add $4 to that cost. So this is our equation to solve. Then the second step says if Clay's destination is 17 miles away and he has $30 in his pocket, will he make it? So the thing that drives this equation is the number of miles. So we're going to take the 17 miles and plug it in for x because that's what x is. And we're going to compare that to the amount of money he has in his pocket because that's going to give us the total cost. And then I can see, does he have enough money? So we're going to take our equation and substitute in that 17 miles so then I'm going to take and I'm going to figure out $1.75 times 17 miles is $29.75 plus $4 is a total of $33.75. So his cab is going to cost him $33.75, but he's only got $30. So you have got to answer your question in a complete sentence. Therefore, ... means therefore, Clay will not have enough money. So you can't just say yes or no. You have to answer it in that complete sentence. Why? Because I said so. All right, good luck on your homework. Let me know if you have any questions. Have a great day.